Hey, we are going to be applying proportional reasoning in mixing situations. All right. So after today, everybody is going to be able to work at Sherwin-Williams. We're going to be able to mix some paint and make some money. Okay. So for our opening question today, earlier in our past or our previous lessons, we mixed green paint. If we wanted to make a lighter shade of green, how did we have to change the ratio of yellow and green paint? What did we have to do to make a lighter shade?
Make the yellow a larger number.
That's right. We needed to have more yellow than, what was the other color? Blue. We're going to be in page 23 today. Okay, so we're going to look at these first two panels of page 1. And basically what we're going to do is we're going to introduce paint mixing scenarios. All right. So we're going to be using the click and pour buttons. Not the click and pour. We're going to be using the pour and mix buttons. All right. And so we're going to use these so that we can find ratios that are equivalent to 1-to-1. All right. So looking at this, you notice our target color is a 1-to-1 ratio of blue to yellow to make green. So we're going to look at slide 2. So if you look at slide 2, it says, what if you want to make double the amount of green paint? So in this case, what did they do to make twice as much paint?
Multiplied.
Yeah, they multiplied by what?
2.
By 2. Levi, would you read that at the bottom in the yellow for us, please, sir?
I can't see it. Where does it say it? In the yellow?
Yeah, in the yellow at the very bottom.
A ratio of 2 parts. Is that right?
Mm-hmm.
It's not yellow for me, but anyway. A ratio of 2 parts blue to pink plus 2 parts of yellow paint makes the same shade of green. This is true because the ratio 2:2 is equivalent to the ratio 1:1. You will create twice as much green paint, but the color will still be the right shade of green.
Great job. Looking at this, what we should notice is that even though we made more paint, the green paint is the exact same color it was when we had a ratio of 1-to-1. So what if I wanted 3 times the amount of paint? What would my new ratio be?
3 and 3?
Good job. It'd be 3-to-3. So let's look at page 3 and see what happens. Oops. All right. So we just took what he just said. We're going to try it right here. We're going to see if 3 and 3 works. If it works, then we will be able to see that we understand how to create this target color. Is this going to give us the same color? What do you think? Is that the same color?
Yes, sir.
Yeah, it is. All right. So somebody give me another mixture.
4 and 4. 5 to 5.
Good job. 4-to-4, 5-to-5. What about 100 to 100? Would that work? Would those all work?
Yes, sir.
Yeah, they would all work. As long as we have the same number of parts of blue as we do yellow, we'll always have a perfect target color, okay? So let's look at number 4, and this is actually in your book on page 23 at question 1A. Goodness. All right, so if you look at it, once again, it says proportional reasoning is useful for painting. Primary colors can be mixed to create many different shades of paint. For example, blue and yellow paint mixed to become different shades of green, depending on the ratios of blue and green added. So what we're going to do right here, it says if you wanted to exactly fill a 1-gallon, 8-pint container with the same shade of green paint, how many pints of yellow and blue should you use? Enter a number of pints for each color, then click the pour and mix buttons. So if I want exactly 8 pints and I want us to have the same number of parts of blue paint to parts of yellow paint, what would get me to exactly 8 pints? What do you think, Hagen?
8 parts blue and 8 and 8, I think.
All right, if we had 8 and 8, would that make 1 gallon or would it make 2 gallons?
2 gallons.
That'd make 2 gallons. In this case, they only want to make 1 gallon. So what do you think, James?
I think possibly 8 to 7.
All right, so if we had 8 to 7, would that give us a 1-to-1 ratio of paint? No, it wouldn't. It wouldn't because we got to have the same number of blue part of paint to yellow parts of paint. So, Miss Jefferson, tell us what you have. Sierra. Go ahead, Sierra.
4 to 4.
4 to 4. All right, explain that to us because we got some people that are kind of confused, and I don't want anyone to be confused on this.
You said 1 gallon is 8 pints and half of 8 is 4.
Great job. So you knew that if you split it in half, that would tell you how much of blue you would need and how much of what's the other color? Yellow we would need, right? Does anybody have a question for Sierra? All right, well, you must have done a fabulous job. Thank you, ma'am. All right, let's keep moving. I'm going to mix this up. As you can tell, it's perfect, okay? It's a perfect mixture. All right, let's see what we get for part 5. I want you to notice that we changed this to 4 from 1 to 1. So I want you to be thinking, what is the scale factor, okay? All right, so what do you think, Angel?
I think the scale factor is 4 because you multiplied 1 times 4 for each one.
You got it. You're amazing. Great job. All right, so when you look at this, we get this. It says when you multiply both parts of the ratio by 4, the resulting ratio is equivalent. So that means equal to. The total amount of paint increases to 8 pints or to 1 gallon from what we just did. Y'all are doing great. Proud of y'all. All right, so let's look at 6. All right, this one, it starts getting a little bit more interesting. Akira, will you read this for us, please?
The blue part?
This part right here.
Experiment with a little bit of paint to make another shade of green. This shade uses 1/4 of hint of blue paint, 3/4 of hint of yellow paint. How could you scale this ratio up to make a gallon of paint in this new shade? How many pints of blue and yellow paint would you need to make a full gallon? Use the drawing tools to help you answer this question.
All right, so looking at this, basically there are 2 pints in 1 quart. All right, so in this case, that would mean that there are 8 pints in 1 whole gallon. And it says this shade uses 1/4 of a pint of blue and 3/4 of a pint of yellow. And it wants us to scale this ratio up to make a gallon. All right, so in other words, what would I need to do so that this is set up to 8 parts instead of 4 parts? What could I do?
4 times 2?
Correct, 4 times 2. Tamarian, if I do 4 times 2, what does my denominator become?
8.
It does become 8. So 1/4, and I'm going to do my best writing here, but 1/4, if we take this and multiply it by 2, anytime we do something to the denominator, we have to do it to the numerator. So 1/4 is equivalent to how many eighths?
2 eighths.
2 eighths. Great job. So that means that our ratio of blue would be 2 pints. So this is blue in here right now. That's our blue paint. So how many more would it take to fill up this whole gallon?
6/8.
6. That's correct. It would be 6. So you could always do 8/8 minus 2/8 and get 6/8. Or we could do the same process that we did a while ago by multiplying by 2 to get our new denominator and our new numerator. So when we do that, just like Tamarian said, we're going to get 6/8. And so that means that we got 6 parts of yellow and we have how many parts of blue?
6.
Ooh, think about how I said it again. We got 6 parts of yellow. So how many parts of blue?
2.
2 parts of blue. Great. All right. So let's take a look at 7. And it's going to show 2 ways to do this. So let's look at strategy 1. Strategy 1 has basically taken each pint and split it in to 4 parts. And so they had 1 part blue and 3 parts yellow, and they went all the way up and they counted them. And so basically 1/4 times 8 equals 2 pints of blue, and 3/4 times 8 equals 6 pints of yellow. Sorry about that. So together, 1/4 pint of blue paint and 3/4 pints of yellow paint make 1 pint of green paint. So to get 8 pints of paint, all we do is multiply by a scale factor of 8. So that's strategy 1. Let's look at strategy 2. All right, so looking at strategy 2, you'll notice that we're taking 1/4 and 3/4, and they are multiplying 1 by 2 and 3 by 2. And so when they do this, they're getting 2 pints of blue paint and 6 pints of yellow paint. So when we look at this, basically what they did was they multiplied by 4 at the beginning to get rid of that denominator and give us our whole numbers. All right. So it's basically saying that the ratio of 1/4 to 3/4 is equivalent to the ratio of 1 to 3. And so just like we said, if we mix 1 pint of blue and 3 pints of yellow, that makes 4 pints. And so if we double that, then we get our new ratio. All right, so looking at this, is there anyone that's confused on why we have 2 parts of blue and 6 parts of yellow? If you got a question, this is a great time to ask. Okay, so looking at this question right here, we should have been able to answer questions 1A and 1B in our book. Okay. Now we're going to look at 1C, and 1C was using the exact same thing that we did. Is there anybody that does not have the answer to part A, B, or C? All right, everybody should have their answer for A, B, and C. What is the answer that you have for C, Kalia?
The answer I have for C is you mean the whole numbers?
Well, read what question C is real quick, and then we'll.
A new shade of green is made using a ratio of blue paint to yellow paint of 1/4 to 3/4. How many pints of blue and yellow paint do you need to make a gallon of this shade of green paint?
All right, and so in this case, how many pints of blue paint did we need?
2.
2, and how many pints of yellow paint did we need?
6.
All right, so everybody should be good on questions A, B, and C.
Mr. Martin, can I go use the bathroom?
Yes. All right, now we're going to go ahead and we're going to look at page 2. So once again, you go up here and you're going to click on the 3 dots and click page 2. And page 2, we're going to be working on this. You're not going to be working in your book right now, so just focus on what we're doing as a whole in class. We're going to just try to have a good discussion about what's going on. So if you would, Tamarian, will you read what is highlighted in this gray here, please. All of this would be perfect.
You can change the shade of the green paint by changing the ratio of yellow and blue paint in the mixture. Play the animation to explore scaling different shades of green paint. The shade of green may use twice as much yellow paint as blue paint. How could you write this relationship as a ratio? What is an
Associated?
associated rate for the ratio?
Great job. All right, so looking at this, we're going to play the video. And so you'll notice that there were 4 parts of blue and how many parts of yellow?
2.
Ooh, count it. We got 4 parts of blue.
Oh.
So there are how many parts of yellow?
6.
Look closely. Think about this. If we have, yes, it is 8. Let's talk about why. Since this is 2 to 1, since we have 2 to 1, anytime that we do anything else, it's going to multiply up. All right. The reason that it's going to multiply up is because we're creating equivalent ratios. And so say we had a scale factor of 2. That means we would multiply both parts by 2. So if we multiply both parts by 2, 2 times 2 is 4. Good. And 1 times 2 is 2. All right. If we did it again and say we went with 3, if we had a scale factor of 3, 2 times 3 is
6.
And 1 times 3 is
3.
all right. And in this case, the one that we were looking at, if we have a scale factor of 4, 2 times 4 is
8.
and 1 times 4 is 4. And so that's the case that we're having because this stands for our yellow and this stands for our blue. Okay? Because they have said yellow parts per blue parts. Okay? So basically what we should notice is there's how many more parts of yellow are there than blue?
Twice as much.
Twice the amount. Great job. That's perfect. All right, so let's keep moving on. I'm going to erase this off of here. And we're going to look at part 2 of page 2. All right, so if we look at this, it says that if you think about the associated rate of yellow paint per blue paint, if you change the rate, you would change the shade of the mixed paint. And you can experiment by moving the rate slider. So we're going to do that. So if we take this rate and move it, if we move it to the left, you'll notice that our paint is pretty dark green. It's kind of our original color. Okay? That's because this is 1-to-1 ratio. But if we change the rate, this is going to make it 2 parts yellow, 1 part blue. What happens to the paint? It does. It's getting a lot lighter. So if we have 3 parts of yellow to 1 part of blue, what's happening now?
It's still getting lighter.
That's right. It's getting lighter and lighter. And eventually, when you get to 5 parts to 1 part, it is almost the same shade of yellow that it was just as itself, by itself. So, what you should notice is every time that we move that rate up, what's happening to the paint?
It's getting lighter.
That's right. So it's affecting the color by getting lighter and lighter. So let's see how we can get more of the mixed paint while maintaining the same color. So let's look at slide 3. So looking at slide 3, it says, what happens if you keep the rate the same, which was 2-to-1, and we just adjust the quantity? When we talk about adjusting the quantity, that means twice as much, triple the amount, quadruple the amount, etc. All right? So if we raise the amount up, Is the color of the paint changing any?
No, you just get more paint.
That's right. We're just getting more paint because all we're doing is we are taking that same ratio and we're multiplying it by a scale factor so it keeps going up. James, do you have a question?
My internet's acting really bad right now.
Okay, that's okay. Just keep trying to make it work. If not, I'm going to be uploading the video later, and if you need to watch it, you can.
Yes, sir.
All right.
Thank you.
You're welcome. Okay, so once again, the amount of yellow paint and the amount of blue paint is staying in the same ratio. It's just getting larger amounts because that's how the quantities are related to our actual paint. And so all we're doing is getting more and more of the same color if our quantity changes. So let's look at number 4. So on number 4, you can experiment with scaling different shades of green, and you can use the rate slider to change the color as well. So if we do this, if we take this and let's say we have 3 parts to 1 part, and I want to see what it looks like when we have more. All right. All we're doing is we're getting more of this same color, okay? So same way here. If I want that dark green and I want a bunch of it, I just keep putting more parts, the same amount of parts of blue as I do yellow, and I get that same color. Now, once we get into, say, a 5-to-1 ratio, it's hard to move this up much because of the amount. These tubes aren't really the right size to keep getting more and more paint because they actually only go up to, I'm assuming we were talking about pints earlier, so 26 pints. So when we look at this, after we get to, I guess, about the third quantity change, we can't go any further because we need more tubes to put more paint in, right? Does everybody see how that's working? Does anybody have a question about how rate and quantity affects the paint, whether it be the color or the amount? Good deal. All right, we're going to go to page 3. So once again, we're going to click the 3 dots. We're going to click page 3. And this is actually going to be question 2 in your workbook, okay? So we're going to be looking at making purple and brown paint, and we're going to practice on finding the scale factor. So if you look at this, we're going to let Miss Kalia, if you would you read this for us, please, ma'am?
Yes, sir. A particular shade of purple paint has a ratio of 1 part blue and 2 parts red. You have 3 part A.
Oh, you're good. Yeah, I mean, I wanted you to read that page, and we can read part A. That's fine.
You have 4 pints of red paint. How many pints of blue paint must you add to make the correct shade of purple?
All right. So if we look at this, it says the red and blue paint will combine to make different shades of purple. This shade has a ratio of 1 part blue to 2 parts red. And we got to enter a number of parts of each color to make the right shade of purple. All right, so when we do this, let's just try, if we used what they originally gave us, they gave us 1 part blue to 2 parts of red. So if we do that, let's see what color we're going to have. So when looking at it, this color and this color are the exact color, all right? So what I want us to try to do is try to think of equivalent ratios that would give us the same target color. So take a minute and try to come up with some. Akira, what is one you have?
2 to 4.
2 to 4. All right, how were you able to come up with that so fast?
Because they're equivalent ratios and they just go up by 2, I guess.
That's correct. Good job. Kalia, what'd you come up with?
6 to 3.
Good job. And so in this case, would it really be 3 to 6 or would we say 6 to 3? What do you think? Would 6 come first or would 3 come first? All right, so let's try it. If we put 6 parts of blue to 3 parts of red, we're going to see if we get the same color. I believe that since we have so many parts of blue, what do you think is going to happen to that target color? I think the target color is going to stay the same, but I think the paint that we mixed, what do you think? You think it might be lighter? I think it might be a little darker. Let's see what happens. Isn't that a little darker than this one?
It is dark.
All right, so what do we need to do so that it's correct? What do we need to do?
Turn it around.
Yeah, all we got to do is turn it around, and then it'll be perfect. So even though the numbers were right, we got to make sure that they're in the right spot so that we have the right number of parts of blue to the right number of parts of red. Because the red's always going to have more parts than the blue, so that we get this. I don't really know what color that is. I'm going to go with maroon. All right, that maroon color. All right, so or magenta. So, Angel, did you have another one? All right. So looking back at that question that we had read for us earlier, it said there were 4 parts of red. So if there's 4 parts of red, Levi, how many parts of blue should we have?
Oh, 8.
All right. If we have 4 parts of red, you think we should have 8 parts of blue?
1, 2.
2. That's right. It would be 2 parts. Good job. So that would be our that'd be our answer for question 2, part A, I believe. All right. Talia, will you read our part B question for us, please?
Yes, sir. Brown paint has a ratio of 1 part purple to 1 part yellow. Remember, you need blue and red in the ratio of 1 to 2 to make purple. List 2 different ratios of blue to red to yellow that will make brown.
Perfect. So we need to focus on creating a couple different ratios so that we can answer our question in part B. And so once again, it says that brown paint is made from blue, red, and yellow. And this shade of brown has a ratio of 1 part of the previous shade of purple to 1 part yellow. So the purple paint is in the ratio of 1 part blue to 2 parts red. And we're supposed to enter a number of parts of each color to make the right shade of brown. And then we're going to pour and mix it together and make sure it matches our target color. All right, just like we were getting a paint chip from the paint store, like we were talking about at the beginning of class. So looking at this, if we just use their actual mixture and use 1 part of blue and 2 parts of red, what is 1 plus 2?
3.
All right, and it said that the violet or the purple color has to have the same number of parts as the yellow. So if blue and red makes up 3 parts, how many parts of yellow do we need to have?
1.
All right, think about this. We got 1 part of blue, 2 parts of red. So in all, that's 3 parts. And so if we have 3 parts of the purple, when they're mixed together, we got to have the same number of yellow parts so that it mixes to match that target color. So if we have 3 parts of violet or purple, we need how many parts of yellow? 3 parts of yellow. So let's see if this matches our target color. All right, so it says very good. Can we find another ratio that would work? Okay, so that would be one answer that we could put in our book. Now we need to figure out if we could come out with another one. So what do you think that we could do, Mr. Levi?
2, 4, and 6.
All right. How'd you come up with that so fast?
I doubled them. I doubled each one of them.
All right. So basically, you created a scale factor, right? And so he's saying that he did 2 times 1 and got 2. 2 times 2 is 4. And 3 times 2 is what? It is 6. All right. So let's pour this and let's see if we get that target color to be exactly the same as our mixture. All right. So looking at this, does it match? Yeah, it does. So tell me this. Is there anyone else that can create one? If you can, raise your hand. The first person to raise their hand will be able to give me theirs. Let's see what we get. All right. Levi raised his hand again. All right, Levi, what'd you come up with?
Ooh, I got a good one. 100, 200, and 300.
Woo! All right, that would work perfect. Great job. I can't put it in there because it's not going to work in that cup. So that is great. Akira.
369.
369. All right. So if we did 1 times 3, that'd be 3. If we did 2 times 3, that'd be 6. And we did 3 times 3, that would be 9. So that would work perfect. I don't think it's going to fit in here because we have a little bitty cup, but we'll try it real quick, okay? All right. It says we entered too many pints and the bucket's going to overflow. But Akira, you are perfectly correct. Levi, you are as well. Does anybody have any questions about that? All right. I would normally have us restate what they said, but since they both gave us different answers, and since we're getting thumbs up, I feel like we got it going on pretty well. So we're going to go ahead and look at part 3. And so this is where it gets a little interesting. All right. Miss Sierra, will you read this, please?
The beginning.
Akira, turn your mic off. All right. Brooklyn, will you read this for us, please, ma'am?
1 gallon.
Good.
Suppose you want to make an example. 1 gallon of brown paint. Remember that the brown paint has a ratio of 1 part purple to 1 part yellow. The purple paint has a ratio of 1 part blue to 2 parts red. Use the drawing tools to help you determine how many pints of blue, red, and yellow paint you can make exactly 1 gallon of the brown paint.
All right. So it's going to get a little interesting here. Let's see what we can come up with. Let's go with Kaylee Adams. I'm going to see if she can help us. All right, Kaylee. Looking at what we got right here, you'll notice that it says we have 8 altogether, and we're going to use 1 part of blue and 2 parts of red. All right, so 1 part plus 2 parts is how many parts in all?
3.
3 parts, okay? So that means that we have 2/3 of red, and we have 1/3 of blue. I don't know why it didn't let me write red there. There we go. All right. So with that being said, we're going to make 8 pints of brown paint. But we know that the purple paint takes up half of our container. So a half gallon is going to be purple. So how many parts is making up the purple paint?
One. Can I be excused real quick?
Yeah, that's fine. All right, so looking at this, we got our purple paint, right? All right, so looking at our purple, what can we do? We need to have the same amount of purple paint as we need yellow paint.
4.
All right, that's right. We got 4 parts of each. So since we got 4 parts of each, what do I need to do with 4 and this 1/3 and this 2/3 to determine how much we're going to have of each? What have we always done with our scale factors? Every time we have a scale factor, what do?
Multiply.
Multiply. So we're going to do the same thing here. We're going to take 4 and we're going to multiply by 1/3. What is 4 times 1/3?
1/12.
Not 1/12. It should be 4/3, which equals 1 and 1/3. So let's try the next one. Let's see if we can do it on our own. What's 4 times 2/3? What's 4 times 2?
8/3.
Good. And 8/3 would simplify to what?
2 and 2/3.
Perfect. All right. Does that make 4 parts if we were to add those together? I'm running out of space, but that's 2 and 2/3. Does 2 and 2/3 plus 1 and 1/3, does that make 4 parts? That makes 4 wholes, right? 2 and 2/3 plus 1 and 1/3. 1/3 plus 2/3 is 1 whole, and 2 plus 1 is 3. So 3 plus 1 is 4. Thanks for participating. All right, so I'm going to erase this off of here. Or try to. All right, and let's look and see what this other student's work looks like. All right, so let's see how they did this. They said 1 and 1/3, which is what we got, plus 2 and 2/3 is what we got, plus 4 equals 8 pints of brown paint. All they did was a whole bunch of coloring, huh? So they did good. So they got 1 and then 2 parts of red, and then they got 1 and 2 parts of red once again. And so all together, they got 4 parts of yellow, and they got 4 parts of the purple. So how does what we did a while ago compare to what they did? Somebody help me out.
They broke it up into more sections.
Yeah, they broke it up into more sections. And even though they broke it up into more sections, once it's all combined, does it give us the same thing? Did they still get 1 and 1/3 and 2 and 2/3?
Yes.
Yeah, they did. And so we know that 4 plus 4 gives us the total amount of pints that gives us 1 full gallon. All right, so let's look at number 4, or part 4 of page 3. So it says another strategy for solving this problem involves a scale factor. So they take 6 and multiply it by the scale factor to get 8. So the reason they're using 6 is because that's what we used earlier making brown paint. They had 1 part of one color, 2 parts of the other to make the purple, and then plus the 3 pints of yellow, and it gave you 6 pints. So now we're going to take that and we're going to be able to make it become 8 pints. So let's see how they do that. So once again, they got a scale factor of 4/3. All right. And so they got that scale factor of 4/3 by using division. All right. So 8 divided by 6, if we simplify that, equals 4/3. And so if you take 4/3 and you multiply it, just like we're fixing to do here, it will show you how they are able to get the same setup that we were. So they took 1 pint of blue from what they gave us earlier, and they took 2 pints of red. And whenever you multiply it by the scale factor of 4/3, it gives you your 1 1/3 pint of blue and your 2 2/3 pints of red. And when we combine those plus the 4 pints of yellow, how many pints do we get in all? How many pints we get in all, Levi? Can't hear you, but I'm seeing your lips move.
8.
8. Good job. All right. So looking at that, that would answer all of your questions on part 2 in your book. Okay. So now what we're going to do is we're going to have a higher order thinking STEM question. So suppose you were given 2 shades of green and one is much darker than the other. What conclusion could you draw about the ratio of blue to yellow in both shades of paint? The blue is actually going to be more parts of blue in the one that's darker in the green than the original. Like, say, for instance, the original shade of green was 1-to-1, and say it had 1 part of blue and I had 1 part of yellow, then I have my original green. But then say my other one's a lot darker, it could have 2 parts of blue and 1 part of yellow. And so therefore that paint's going to be darker. And that's what Levi was trying to say. All right. So we're actually going to have more practice on this. And so what you're going to do is you're going to click on more practice in your assignment whenever you click on assignment, and it's going to take you here. And so when you go here, there's going to be 5 questions that you're going to do, and they will basically make sure that you completely understand what we've been going over. And so you'll be ready for an assessment that's coming up here shortly. Not this week, but very soon.